Hi guys, if you have questions, email me or write a comment.
Hi, today we're going to talk about trigonometric identities, some of the fundamental identities. If you remember in the basic trigonometry video, I have explained how do we got the reciprocal identities, so we need to revise these. What we said was secant any angle is equal to 1 over. As I said, to remember this, whatever start with S takes what start with C, and keep in mind that sine and cosine are the basics. So this will be 1 over cosine theta. And also we said cosecant theta will be equal to 1 over sine theta. Same thing for tan and cotan. Cotan theta will be equal to 1 over tan theta. And of course, same thing. I can write cosine as 1 over secant. I can write sine as 1 over cosecant. I can write tan as 1 over cotan. And since tan is equal to opposite over adjacent, so also tan, as we said before, can be written as sine theta over cosine theta. Same thing for cotan, can be written as cosine theta over sine theta. Now, where do we need these identities? We'll need them to simplify some problems, like, for example, let's say we have this simple example. We have cosine theta times tan theta, for example. If I want to simplify this expression, how would I do that? Simply, cosine theta will just keep it. Tan theta can be written as what we said here, sine over cosine. So this will be sine theta over cosine theta, which means we can simply simplify cosine with cosine. So the answer will be equal to sine theta. So the simplest form of cosine times tan is equal to sine theta only. Well, these are the basics here. And we also talked about the Pythagorean identities, which were sine squared theta plus cosine squared theta will always be equal to 1, as long as I'm talking about the same angle, of course. Note that here I'm talking about theta and the same angle, theta. So sine squared plus cosine squared for any angle will always be equal to 1. Same thing happens when you talk about secant squared. Secant squared is always equal to 1 plus tan squared theta, and cosecant squared is equal to 1 plus cotan squared theta. Keep in mind that these are equations, so I can flip whatever I want. So in case I want to write sine squared only, what would I say? Sine squared theta is equal to 1 minus cosine squared theta. And same thing can happen for cosine. So if I want to write cosine squared alone, I would say cosine squared theta is equal to 1 minus sine squared theta, if you move sine to the other side. Same thing happens here. I can move tan to the other side or secant to the other side. So if you say secant squared minus tan squared, that will be equal to 1. Same thing here. It can be written as cosecant squared minus cotan squared, and that will be equal to 1. Good. How am I gonna use these? Let's have a look at an example here. For example, let's say that we have cosine squared x times 1 plus tan squared x. If I want to simplify this, what would I do? Well, we know that 1 plus tan squared is equal to secant squared. So I can replace the whole expression here by secant squared. So this will be equal to cosine squared x times secant squared x. And we also know that secant is equal to 1 over cosine. So you can replace secant to be 1 over cosine. So this will be cosine squared x times 1 over, this is secant squared, so cosine squared x again. You simplify cosine with cosine, cosine squared with cosine squared, and the answer will be equal to 1. So this whole expression is actually equal to 1. This is why we need to try to simplify expressions using trigonometric identities. Well, actually we have some other trigonometric identities. We have the odd and even identities. What do we mean by that? We mean sine negative theta or negative x, which is the way of checking if a function is odd or even, if you remember. So what is sine negative theta? What is cosine negative theta? What is tan negative theta? Well, I think I will leave the answer for you. Just look at this and try to remember. What do we have? Let's say, I want to remind you, when do we have positive and negative angles? As we said before, all students takes calculus, right? Or A means all sine, cosine, and tan are positive. In the second quadrant, only the sine is positive. In the third quadrant, only the tan is positive. In the fourth, only cosine is positive. Now, what's the relation between this and what I'm talking about here? Simply, when you see such thing, there is no need to memorize it. Just think of theta as an acute angle. So when I say negative theta, this means I'm talking about an angle in the fourth quadrant. So this is negative theta, which means sine, cosine, tan, cotan, secant, all of them have a reference angle, theta, right? So it's the same trigonometric ratio, the same answer with different signs. Now in the fourth quadrant, only the cosine is positive, which means cosine negative theta is the same as cosine its reference theta. Sine negative theta is the same as sine its reference but negative. Tan negative theta is the same as tan its reference angle but negative, since we are talking about an angle in the fourth quadrant. So this can be simply memorized. No need to memorize it actually, you can just figure it out. An example on this, let's say we have, for example, tan theta plus cosine negative theta plus tan negative theta. Let's say we have this. How am I going to simplify this expression? Well, we have negatives, so first of all we have to get rid of the negatives inside the angle. Tan theta, let's take it down. So tan theta, cosine negative theta, as we said, it's equal to cosine theta. So plus cosine theta. Tan negative theta, we said it's negative tan theta. Negative tan theta. So this will be minus tan theta instead of a plus. Now what do we have? We have positive tan, negative tan. This will be crossed out. So the simplified form of this is cosine theta only. So this whole expression can be written as cosine theta only. These are the main identities, the main fundamental identities, but let's have a closer look of something that we talked about at the introduction of trigonometry. In the introduction, we said that sine 30 degrees is the same as cosine 60 degrees, if you remember. And what is 30 and 60? 30 and 60 are complementary angles, so 30 plus 60 is equal to 90 degrees. They are complementary angles. What does that mean? This actually means that sine 30 can be written as sine 90 minus 60. So 90 minus 60 equals cosine 60, right? Have a look at this. Sine 90 minus 60 is the same as cosine 60. So this is general actually. We can say that sine 90, which is pi over 2, minus theta will always be equal to cosine theta. And the same thing happens if I want to write it in cosine. So cosine pi over 2 minus theta is the same as sine theta. And actually, same thing can be applied for tan, cotan, secant, and cosecant. So you can say that tan 90 minus theta is equal to cotan theta. Same thing for secant, cosecant, and cotan. As I said, these are the main trigonometric identities, the fundamental ones that you need to memorize. Let's have a general look at them again. We talked about the reciprocal identities. We talked about the Pythagorean identities. We talked about odd even identities and the co-function identities. I hope that this was simple and easy. You need to do some practice on this, and good luck.
Remember to like, share, and subscribe, and write your questions via email or comments.